Hello, I'm Bono. With this video, we begin the theory edition of the Electric Circuits textbook series. It's a course where you can learn the world of electricity truly from zero, in order and systematically. After you've got a solid grip on the theory, a practical edition is also planned to follow. In fact, I spent more than a month designing this series, carefully working out what to teach and in what order. I've also checked every piece of the content myself, so I'm delivering it to you with confidence. In this first video, let's take a look together at the big picture of what we are going to learn. Please do watch all the way to the end. First, let me talk about who this course is for. You can start with middle school level math, but to be honest with you, this is not a course you can understand with no math at all. Around AC, transient phenomena, and control, we'll also use high school level ideas like trigonometry, complex numbers, and calculus. Each time they appear, I'll break them down and fill them in as much as I can, so whether you come from a non-STEM background, you're a beginner, or you're relearning, there's no need to brace yourself at this point. That said, I'll also be honest that this is not an easy shortcut. Understanding takes time spent working things out with your own hands. Even so, I've built it so that if you go one step at a time, you'll definitely gain real ability. So I especially hope this reaches people who want to work in the field someday, who want to properly build a foundation through self-study or work, and who have the will to see it through, even one step at a time. If you're serious, I'll guide you all the way. Let me take just a moment to tell you the background, why I decided to make this series. There are three motivations. The first is the need for a place to learn electricity systematically. For a long time, I've been sharing electronics and technology on YouTube, and I felt there were still very few places where you could learn electricity in proper order, rather than in fragments. The second is that demand in the field is growing. With the arrival of the AI era, and as the working population shrinks, both the companies that want people in the field and the people who want to work in the field are increasing. I want to help bridge the two. And the third is that the environment to make the ideal teaching material has finally come together. I'd long wanted to make proper material, but I never had the time to bring it to life. With the arrival of AI, I've finally been able to make it real. So once you finish this theory edition, how far will you be able to go? What we are aiming for is a theoretical foundation in electricity that holds up in the field. Not just memorizing formulas, but reaching a state where you understand the basic theory of electricity, electronics, logic, and control, connected from why it works that way. Concretely, understanding what circuit diagrams and symbols mean. Being able to explain how things work in your own words, and being able to follow conversations and documents between engineers. That's where I set the goal of the theory edition. The hands-on parts, actual part selection, measurement, and design judgment will be covered in the practical edition, planned to follow this theory edition. For now, let's build that foundation solidly here in the theory edition. Now, let's look at the whole map of the series. This theory edition is made of 4 big steps. First, part 1 is electric circuits. Next, part 2 is electronic circuits. Then part 3 is logic circuits. And finally, part 4 is power electronics and control. This order has meaning. Each block is the foundation for the next one. So, as a rule, I recommend following this map and proceeding from the front in order. And note that this theory edition doesn't end at part 4. I plan to keep adding to it beyond that. Now let me introduce each part one by one. First, part 1, electric circuits. Here we start from the basics of DC circuits, move through Ohm's law and AC, and go all the way to transient phenomena that change over time. This is in a sense the part that builds your basic stamina in electricity. It's the foundation for everything that follows, and the most important place. Let's look a little more closely at what you'll learn in part 1. First, the basics of DC circuits. We firm up the foundations. Circuit symbols, current and voltage and ground, From there we move on to Ohm's law, and to calculations of power and series and parallel. Then come the theorems for solving circuits, the capacitors and coils that store electricity, and on to AC circuits. Finally, we cover AC power, three-phase AC, and transient phenomena. By the time you get through this, your basic stamina in electricity will be firmly in place. Next part 2. Electronic circuits. Here, components like semiconductors, diodes, transistors, and op-amps make their appearance. Using these, you'll learn the techniques for handling signals, making a small signal larger, changing its shape, and so on. This is the part where the insides of the electronic devices around you gradually come into view. Let's line up what you will learn in part 2 as well. First, how semiconductors and diodes work. From there, we move on to rectifier circuits and power supplies that shape electricity into clean DC. Next come the operation of transistors, the amplifier circuits that use them, and the op-amp, the star of amplification. You'll come to understand what each component is there for. Next, part 3, logic circuits. Here, using just two numbers, 0 and 1, you'll learn how the insides of a computer are built by combining logic gates to calculate and to remember. This is the part where you touch the very deepest workings of the computer you use so casually every day. Let's look at what you'll learn in part 3. There are 4 chapters in all. The first chapter is the basics of binary and logic circuits, the foundations of binary, Boolean algebra, and logic gates. The second is combinational circuits, which combine them. The third is sequential circuits and flip-flops that hold memory, plus counters and registers. And the final, 4th chapter goes on to memory and to add/de conversion, which converts between analog and digital. You will come to see how a computer achieves calculation and memory. And finally, part 4, power, electronics, and control. Using everything you've learned so far, electricity, electronics, and logic, you'll go all the way to driving power supplies and motors and commanding them at will. The power supply circuits that convert electricity skillfully, the drive circuits that turn motors, and the control that commands them as you intend. This is the part where you get a real sense of how what you've learned connects to real-world making. Let's line up what you'll learn in part 4. First, power supply circuits. You'll learn the workings of DC-DC and switching that convert electricity efficiently. Next, the circuits that drive motors. We move on to the various kinds of motors and their drive circuits. And the second half is control engineering. Starting from the idea of feedback, we cover a system's response and stability, and the representative PID control. By the time you get here, a world opens up where you use what you've learned to move machines yourself and command them at will. Finally, let me give you just 3 tips on how to go through this series. The first is to watch in order, following the map. Each block is the foundation for the next, so order matters. The second is, if you get stuck, don't hesitate to go back to an earlier video. What you don't understand usually has its cause one step before. The third is that each video covers just one theme, so it's perfectly fine to go little by little at your own pace. There may be times when it feels difficult, but I built it so that if you go one step at a time, you'll definitely understand. Let's move forward together at your pace. And now it's time for the very first step. That's all for this time. Thank you for watching.